Hello, welcome. In this short video, let us look at another example illustrating the application of linearity property for finding the Z transform of a composite signal. So consider the signal x of n defined as 1 by 3 power n minus 2 power n for n greater than or equal to 0 and 0 for n less than 0. That is given this causal signal, which is basically combination of these two components. So we can rewrite x of n as x1 of n minus x2 of n, where x1 of n is simply 1 by 3 power n u of n and x2 of n is 2 power n u of n. So now we can determine the Z transform of the overall signal, that is x1 minus x2, that is x1 of n minus x2 of n, by simply applying the linearity property. So for that purpose, first we have to find x1 of z, that is the Z transform of x1 of n, which is given by 1 by 1 minus 1 by 3 into z inverse, that is based on the Z transform of alpha power n u of n. Here alpha is basically 1 by 3 and the ROC is mod z greater than 1 by 3. That is, the ROC is the whole z plane outside the circle of radius 1 by 3. So this is the Z transform of the first component. And for the second component x2 of z, the Z transform is again given by 1 by 1 minus 2 into z inverse. And the ROC is mod z greater than mod z greater than 2. That is, the ROC is the whole z plane outside the circle of radius 2. So these are the two Z transforms. Now we can combine them to find the overall Z transform. That is, x of z is equal to x1 of z minus x2 of z. So which is obviously equal to 1 by 1 minus 1 by 3 z inverse minus 1 by 1 minus 2 times z inverse. And the combined ROC is basically the intersection of these two ROCs. That is, the ROC of x1 of z is the whole z plane outside the circle of radius 1 by 3. So this is the ROC of the x1 of z. And for the ROC of x2 of z, that is the second component or the second Z transform, it is again the whole z plane outside the circle of radius 2. So this is the ROC of x2 of z. Now for the combined signal for x of n and for the corresponding x of z, the ROC is intersection of these two, which is obviously the whole region outside the circle of radius 2, because this is the circle with larger radius. So the intersection is obviously this ROC. So therefore the ROC of the x of z is again the whole z plane outside the circle of radius 2. So the corresponding ROC is mod z greater than 2. So that is the intersection of these two ROCs. So to summarize, we have used the linearity property to find the Z transform of a composite signal. That is, we have two components. The first one is 1 by 3 power n u of n, second one is 2 power n u of n, and x of n is the difference between these two signals. So by simply applying the Z transform formula for alpha power n u of n, that is the Z transform of alpha power n u of n, we have determined the Z transforms of these two components. That is, the first one is 1 by 1 minus 1 by 3 z inverse. The second one is 1 by 1 minus 2 z inverse. And the corresponding ROCs are mod z greater than 1 by 3 and mod z greater than 2. That is, these ROCs are basically the whole z plane outside the corresponding radii. Now to find the combined Z transform, that is the Z transform x of z, which is basically x1 of z minus x2 of z, that is based on the linearity property, is given by this difference, that is 1 by 1 minus 1 by 3 z inverse minus 1 by 1 minus 2 z inverse. And the overall ROC is basically the intersection, which is the region outside the circle of radius 2, that is mod z greater than 2. And note that in this problem, if 1 by 3, that is, if this 1 by 3 is replaced by 3, that is 3 power, and that is, if x of n is given by 3 power n minus 2 power n, that is, if x of n were equal to 3 power n minus 2 power n for n positives, that is for n greater than or equal to 0 and 0 elsewhere, then the problem will be slightly different. That is, the Z transform will be x of z will be simply 1 by 1 minus 3 z inverse minus 1 by 1 minus 2z inverse. And the corresponding ROC will be mod z greater than 3 because the radius 3 is greater than radius 2. So the z transform will be slightly different, that is 1 by 1 minus 3z inverse minus 1 by 1 minus 2z inverse. So mod and the ROC will be mod z greater than 3. That means for finding the intersection we have to determine in this case whichever circle has the larger radius, so that will give us the overall ROC. Thanks for watching.